In this video, we'll talk about how to compute binomial probabilities. So let's look at a problem where we have a six-sided die, and we'll say that it's being rolled 7 times. Now this is a binomial probability in part because we have a fixed number of trials. So we have 7 trials. We decided that at the beginning. So we know that there's going to be 7 trials, and that's what we mean by a fixed number of trials, as opposed to, say, rolling the die until it comes up a 4. So that would not be a fixed number of trials. But here we're going to roll 7 times exactly, fixed number of trials. Now, in a binomial probability, there has to be just success and failure. And when we roll a die, generally speaking, there are 6 outcomes. But we're going to define success in this problem as rolling a 1 or a 2. And that means failure would be rolling a 3, 4, 5, or 6. So since success is rolling a 1 or a 2, then every time we roll the die, we have a 1/3 probability of success. So we always have the same probability of success because every time you roll the die, we're starting fresh. So 1/3 probability of success because we could get either a 1 or a 2 out of the 6 possibilities. That's 2 out of 6, which simplifies to 1/3. So now we're going to calculate the probability, the binomial probability, of x successes, and we're going to let x take on every possible value, which is everything from 0 up through 7, because we're rolling 7 times. So maybe you never get a 1 or a 2, right? You could roll 7 sixes. Who knows? It's possible. So there could be 0 successes, so we'll calculate the probability of exactly 0 successes. Then we'll find the probability of exactly 1 success, probability of exactly 2 successes, all the way up to a maximum of 7 successes, because of course you can never succeed more than you try, which is a good life lesson as well as good mathematics. Okay, so here we've got a lot of information on this screen. So if we have 0 successes, we can calculate the probability of 0 successes using your graphing calculator. And what we'll do is press the second button, and vars, and you'll find the vars button. Let's see. Let me take a look at my calculator where it is exactly. Oh, it's right to the left of the clear button. So that's where you'll find your vars button. And then you scroll up until you find the binom PDF function. And notice that we're using a P right here. We're going to use the CDF function later on. But for right now, we're going to use binom PDF function. So we choose binom PDF, and we have 7 trials in this case. You may have a stat wizard that prompts you with the word trials, or you may just give the number of trials first, either way. Probability of success is 1/3, and we're going to look for 0 successes. We want the probability of 0 successes here, so we put a 0 as the 3rd value. So whether you're using a stat wizard or not in your calculator, you're always going to give the numbers in the same order. So it's number of trials, probability of success, and then how many successes we're looking for. And when you press enter, then you get 0.0585. And if you are using the stat wizard, you're going to have to press enter twice to get there. All right, so that's the probability of 0 successes. Now the probability of exactly 1 success. So probability of 1 success, binom PDF again, 7 trials, probability of success 1/3, and we put in a 1. Now we have 0.2048, so that's gone up quite a bit from the first one. So it's much more likely that we would have one success than none at all. Then we find the probability of exactly 2 successes, and we use the PDF function again, 7 1/3 2, and we get 0.3073. So now try this on your calculator. Again, use Binomial PDF. For the next one, we're looking for 3 successes, so it's going to be 7, 1/3, 3, and you should get 0.2561. For 4, you get 0.1280. For 5, it's 0.0384. And you can, of course, pause this video if you need to in order to type that all in. I don't think you can type quite that fast as I'm going. Probability of 6 successes is 0.0064. Now here's a little bit of a tricky one. When we get to probability of 7 successes, what you get is your answer, and I wrote the whole thing out. Normally we would round to 4 decimal places, and I should have mentioned that before. So all of these I've rounded to 4 decimal places. This one I wrote out because it's given in scientific notation. And how I know that is because it's got this E-4 on the end. So whenever you see that E and then a negative something, it's always going to be negative in this particular class because it's only going to come up when we have probabilities. So E-4 here we have in this particular case. So what I'm going to do is I take the number that we have here. Let me write it over here. So I've got 4.5724 da da da. I don't need all that. And it's E-4, which means times 10 to the -4 power. So what you do is you're going to move your decimal point 4 places to the left. So I'm going to go 1, 2, 3, 4 places over and put in a decimal point. In every empty loop, I put in a 0. So now I've got 0.000457724 blah blah blah. And because we're rounding to 4 decimal places, then I look at the 5. That is going to round the next number up 1. So we wind up with 0.0005 as our final answer there, rounded to 4 decimal places. So that's how scientific notation works. Okay, I jumped there pretty quick. So let me go back. So here we have the probability of each particular number of successes, and of course we have to have anywhere from 0 to 7 successes because there were 7 trials. So you can't succeed less than 0 times, and you can't succeed more than 7 times if you're only trying 7 times. So now let's look at something a little bit more complicated, and I think I'm going to have to make a second video for this, so I'm going to stop this video here.